incubation, inauguration of this setup, and also Nasi and Infra conference, Science to Society. So what we can do, even with Sophitorium, using as one of the platform, can we have some cancer awareness program? We have lot of doctors in our medical college, KIMS. I collaborate with Bhubaneswar. I also had a couple of meeting with Acharya Harihar Cancer Center, Dr. Lalatendu Saringi, and one of my office at Medical College, KIT, KIMS. And we have also super specialty hospital, and we have new cancer center 2 years back inaugurated by Mr. Nobin Patnaik. So why I'm saying this, I'll just justify this. You know that if you go 3 family, your neighbor or your relatives, out of 3 family, you will find out 1 or 2% develop cancer. Either grandmother, grandfather, or father or mother, or uncle, or aunt, or whoever. Either breast cancer, or prostate cancer, or ovarian cancer, or lung cancer, or head and neck oral cancer, or brain cancer, etc. The treatment for this, in general, what is going on last 2, 3, 4, 5 decades, that when they are developing, first of all, country like India, our awareness is very less. When we detect cancer, they are already in the stage 2, stage 3. So therefore, it's too late to cure cancer. If it can be detected at the early stage 1, stage 2, then you can cure them with a different treatment. Therefore, cancer awareness, like National Cancer Institute, National Institute of Health, USA, this is world top funding, NIH, where earlier days I spent 5 years there. And they spent millions and millions dollars for cancer awareness. And cancer is a disease now, this is the #1 disease compared to diabetes, compared to cardiovascular, heart disease, and many other diseases. So classical treatment for cancer, when patients coming to the hospital, clinic, and when that see that cancer detected, only treatment surgery or neoadjuvant therapy. Neoadjuvant therapy means doctors will give chemotherapy to shrink the cancer, to reduce the size of the cancer. After that, they will go for surgery, or if they are not giving neoadjuvant therapy, then they will do surgery and give chemotherapy and radiation therapy, chemo and radiation therapy. And I am closely watching AIMS Bhubaneswar, then your Acharya Harihar Cancer Center, and then Subrot Bagchi started that excellent cancer center, Care Hospital, then Apollo, then our KIMS KCC Cancer Center. So even Odisha also, there's a huge incidence of cancer, different kind of cancer, because it's depending on the different geographical location, because of different food habits. We have a 63 tribal population across Odisha. The tribal people, their lifestyle are different. They are developing cancer, where men life, they are changing. And that of social science, KISS, has a 40,000 students. So we have started those and also when they are. So other than the chemo and radiation therapy, now almost 1 decade, next line of therapy and treatment going on, and also immune therapy, these two. to next slide, that immune cells also plays important role because unlike heart disease or diabetes or any other disease, cancer is little more complex and complicated. Because of the tumor microenvironment, there is a lot of heterogeneity. If the two women developing breast cancer, their nature and type of cancer and their treatment and therapy may not work with the same drugs for these two women because of heterogeneity. And why heterogeneity? Because there are all different kind of cells. They are present in the tumor vicinity, tumor microenvironment. Within the tumor vicinity, that is called stromal environment, and they express many immune cells, macrophage, T cells, endothelial cells. There is a cancer stem cell. Then you have a fibroblast. You have epithelial cells. So they are all present here, and they express different kind of proteins and genes. So depending on the nature and type of cancer, it varies that how what kind of cells are more important, whether tumor cells or stromal cells, and what kind of genes or proteins they are expressing. For example, that breast cancer, that is last 20-30 years we are working. So if you the structure of this, there are two components here. One called lobules, another called duct. So milk synthesized and stored here. So here two type of cancer develops for breast cancer patient. One called lobular cancer, another called ductal cancer or ductal carcinoma in situ. And if you cross section this duct, it looks like this. It's all normal duct epithelial cells. When they become cancerous or malignant, these cancer cells grow within the duct. And then cancer cells, they expand, proliferate much faster. So they invade out of this duct. That is called invasive ductal carcinoma. And that is the way doctor, based on their pathological, histopathological, immunohistochemical test, they identify which category and accordingly they design the treatment. But there are subtypes. There are classification within the breast cancer. Some of them they call luminal A, where that hormone receptor, estrogen and progesterone receptor positive, and then human epidermal growth factor receptor HER2 negative, luminal B all three positive, third one ER and PR negative but HER2 positive, and the fourth one is the most important in India as well as other part of the country, that is called basal-like or TNBC or triple negative breast cancer, where all three are negative. There is another one called inflammatory breast cancer. This is very uncommon in India. In this case, that whole organ become inflamed. That is called IBC. But major problem with that TNBC. Why problem? Because women even before marriage and because of multiple factors, because of sporadic factors, they are developing this. This is very, very aggressive as compared to luminal A, B and HER2 positive. In case of luminal AB, usually the women, they are developing cancer at the age of 60, 65 plus. But in case of TNBC, we have data from Tata Memorial Hospital, TMH. Now I am running two projects with AIMS Delhi. So the data coming that age of 27, 29, 30, 31, they are developing this TNBC. So that is why it's more challenging and alarming, and government spending good amount of money. It starts with a little lump, you can see here and there. And this lump, ultimately, they grow further and then they develop this at the primary site and then they target to the lymph node. So it metastasizes to the lymph node, lymphatic tissues, and from there it spread to lung, liver, brain, and bone. Many of the patients, they die because of lung metastasis, liver metastasis, or skeletal or bone metastasis or brain metastasis. Same thing happen in prostate cancer for male. So this is one of the project we just completed, started 2017 and ended 2024, about 11 crore 50 lakhs. This is a collaborative project funded by DBT. When I started, I was National Center Cell Science NCCS Pune, along with Tata Memorial Hospital. Then I transferred, 2019, I transferred to KIIT. Then Institute of Bioinformatics, Bangalore, National Institute of Biomedical Genetics, West Bengal, Kalyani, West Bengal, and ACTREC, Mumbai, Data Cancer Center. So objectives are different, and this is very novel objective. Nobody has done in India this kind of study. What we have done, we collected the patient tissue and directly implanted into the animal and developed the model called PDX, patient-derived xenograft. So through this multicentric approach, and my team and our group, our role was to develop this PDX model, patient-derived xenograft. Patient sample came from Tata Memorial Hospital and it is implanted to our facility. And once you develop this model, why you need this model? Once you develop this model, then you can screen new drugs for the drug development. Second thing, once you develop this model, these tissues can be used for genomics and proteomics study to identify what are the novel targets, because this is patient specific. One patient, we can develop one PDX model. This is the type of research going on 10, 15 years in Singapore, US, Europe, Australia, other country. Because you are expanding the tumor, collecting the patient's little sample, expanding, and then you go for genetic profiling, genomics analysis, and identify what are the genes and proteins are involved. Then accordingly, doctor will design the therapy. And that is the best way to cure it. So that was the purpose of this. We also established primary culture, and then from this model, we have done genomics and proteomics through our collaboration. So this is how we have addressed. And there are two types of. Another problem with the cancer patients, when they are developing cancer and going through that chemo cycle, after first cycle, when they are going through second or third phase of cycle, the same drugs, they are developing resistance because drugs is not working. That is the major challenge, not only breast, any cancer. And because of drug resistance, so your drugs will not work, no matter you are giving second time, third time, or fourth time. So this is challenging. So part of this project, how to overcome the resistance. So we collected the resistant patient, breast cancer patient, and sensitive breast cancer patient, and developed this model. And we moved to first generation, to second, to third, to fourth, like that. So these are the patient's code number, ID number, and this is how that date we have collected sample. So it came from Mumbai to Pune within 2 to 3 hours by car. And immediately we process it and implant it. That is the way it has been done. These are the representative tumor, what you can see, you will see better here. And that time 2 students were working. And so this is, once you generate this tumor, then you can establish primary culture and you have to characterize, make sure what you see in the patient, same thing you are observing in the PDX. So these are the specific signature and marker. By confocal immunofluorescence, we have shown, yes, they are correlating with the patient sample. Then we gone to next generation, G1 to G2, and this is the patient code number, P014R. Again, we have further characterized by using ER alpha, PR alpha, HER2, Ki67 proliferation marker, EMT marker, NCAD, ECAD, alpha SMA, etc. So they are showing positive. So then we have done some genomic studies. What are the genes they are differentially expressing between patient versus generation 1 or generation 2? and we analyze this gene, and because that way you will find that molecular target. So this is the sum of the genes we find. They are very selective based on the genomic studies, and then we validated some of the gene, and then that paper we have published. First paper came from India based on that PDX model. Now I'm just showing to what are the new activities going on at KIIT Bhubaneswar. As I said, I collaborate with many different government and non-government research laboratory, research institute, university, and outside India. Because unless until your level is, your expertise is not same, it's very difficult to collaborate. It's difficult to bring the grant. But that I succeeded last 30 years. One of the project, this is the running project, 1 crore 19 lakhs with AIMS Delhi. I am the coordinator. This is basically PAM50 is a combination of 50 genes which are expressed in the breast cancer patient. So we are screening the patient based on these PAM50 genes. That's why the title integrated assessment of to improve the efficacy of gene expression based P50 classifier with some additional marker in breast cancer using PDX platform. Now we have expertise how to develop PDX. So this is with AIMS Delhi and my center KIIT. This is going on. So this is first year we are completing. We have 2 more years, and they are also doing some mutation analysis and other. Because in case of breast cancer, 90% of patients they develop because of sporadic factors, and another 10% because of genetic factors like mutation of BRCA1, BRCA2, P53, etc. Again, I'm just showing how you can establish new collaboration. So with my own interest, I gone to Acharya Harihar Cancer Center, met their director, dean, and now the problem with Indian breast cancer patients, their survival rate is 60%, 60 to 66. When they are developing stage 2, stage 3 breast cancer, only 60 to 66% patient they survive, remaining they die. Whereas international level survival rate 88%. So now Government of India through Ministry of Health, ICMR, they started new program. How Indian patients, their survival rate can increase from 66 to 88%. So this is again, I with association of Acharya Harihar Regional Cancer Center, AHRCC, developed the program. The program just initiated because we did not get the funding yet. Along with our KIMS Medical College, School of Biotech, and AHRCC, to develop strategy hence the stage 2 breast cancer survival rate and improve the overall quality of life of women in Odisha. These are the type of thing I like. The Sophitorium should take some initiatives through your ITBI, through your research lab in collaboration with neighboring institute like NISER, ILS, KIT, or other hospitals like this. So there is a 5 genes. These genes are very important for the detection of breast cancer. And I am not going details. These are the 5 gene signature. And based on that, you can screen it so that you can improve that survival rate from 66 to 88%. Now I'll just spend few minutes how to develop that nanoparticle mediated drugs for nanotechnology come major way for cancer treatment. It does many things for agriculture, for engineering, for other things. But why nanotechnology? Why nanoparticle? Because advantage of nanoparticle mediated drug delivery, because here you can have a targeted drug delivery. The drugs will reach to the specific target rather than giving only drugs alone without nanoparticle. Because you are using some receptor mediated delivery or some targeted delivery. And this all again, with my earlier chemistry background, we understand that all these conjugation chemistry for making nano drugs. So I collaborate with IIT Bombay for this purpose. National Chemical Laboratory, NCL Pune, ICGB New Delhi, and some other organizations. And now KIIT University also, they have material science, applied science, etc. So you can see there's a huge market. I like to see some of that starters and innovations should start at ITBI based on that nanotechnology based platform for diagnostic as well as therapeutic purpose, as well as application of material science for agriculture, environment related area. Because this is also, they have huge potential. Even automobile, even dental science. Dental science, whatever that, when you have a root canal therapy, the material which you use, some of them, they are nanomaterials. So, and there are different kind of nanomaterials like a lysosome, polymeric nanomaterial, albumin-based nanoparticle. There are many metal oxide, iron, zinc, copper, titanium. So many of them, they are in that dye industry, they are in automobile, they are in healthcare, they are agriculture, for repellent, many other purpose. So we use one selective nanoparticle. This is US FDA, US Food and Drug Administration. They approve this particle for management of wound. Wound care, wound management, again another issue. When somebody develop diabetes or somebody has a burn, because of burning, it creates wound. But you have to heal the wound. So there people are using nanoparticle. They are making a sheet along with the drugs. And this particle itself has an anti-inflammatory, anti-cancer activity. So that's why last 8 to 10 years, we are using that particle, and that particle we are tagging with a, making some conjugation chemistry with a protein of gene which we are working. This protein has a tripeptide motif called RGD or GRGDS. This protein called osteopontin. So what we are doing, as I said, I understand chemistry very much. So we make the chitosan particle. There is a procedure. You conjugate, make a covalent bond with a cross-linking reagent called SPDP, and then use the cyclic peptide and make this linkage. And after that, you use any drugs of interest you want with this RGD chitosan conjugation, and then deliver to patient or animal model or cell line. So this we succeeded. There is a drugs called raloxifene. These drugs used for the treatment of breast cancer. And only free drugs give some lot of adverse effect. But if you make a raloxifene chitosan nanoparticle or raloxifene RGD chitosan nanoparticle, these are more selective. So we have done all these size, zeta potential analysis. I'm not going through all details. And then we have checked that in cancer cell how it works. Then we have shown that it inhibits cancer cell migration and angiogenesis. And then we have shown by label this nanoformulation, you can see that it is targeting to the tumor. That we have shown by the technique called in vivo imaging system, which works based on the fluorescence and immunoluminescence. And then we further shown that this nano drug formulation, basically it enhances the cellular uptake in the cancer cell, which we have shown. And we have shown also it has a anti-angiogenic potential. Then we checked some of the mode of action and mechanism. So it works through some of the pathways. I am not going through details. What is important, we directly made that cancer model and then tested these nano drugs. There are other control free drugs, and this is the actual peptide nanoparticle and drugs conjugation. You can see compared to control, there is a huge reduction of the tumor, both the tumor volume and tumor weight. So that means it works. Then I have 2-3 more slides just now. So then we are very good like a the way that outside pathology lab works. So we do histopathology, immune histochemistry. These are done. And then we gone one step further. If these drugs, nano drugs, need to move to the next step, you have to do the toxicity study. In vitro and in vivo, particularly animal testing, acute and chronic toxicity. These are again part of that incubation center can do it. So we have done these hematological and biochemical parameter studies. We find that normal mice, they are non-toxic in nature. So then this is the last slide. So basically this nanocarrier showed impressive chemotherapeutic efficacy with high biocompatibility and hold a great potential for clinical application. It when the cancer develop, they are acidic in nature. So we have tested low pH 5.8 versus 7. It works better in low pH, acidic pH, and it's targeted and effective drug delivery. This is the model. This paper published, and that students now he's gone to Sweden for his higher study. So there are selective publication based on that nanomedicine research, and you can see that my students, I think some more they got PhD doctorate degree 23 plus 1 24, and this list is not complete because KIT I have this year taken 5 more students. So here I have 15 total students, and this collaboration all over the world, some of them not listed here, and funding DBT, BIRAC, ACRB, DST, Indo-German, ICMR, and now JC Bose. Also, this my award also give funding, Government of India for next 4-5 years. These are some of the earlier students. Usually my lab has 15 to 20 student average last 30 years. Some students, and these are students at KIT University. Some of them here also. So with this, I'll stop it here. Thank you very much for your attention. And that was my award given by Dr. Manmohan Singh back in 2004, Santi Sarup Bhatnagar Award, along with Mr. Kopil Sipal. That time he was Science and Technology Minister. Thank you. I have a small question. Sorry. This cytosine is a very long chain compound with high molecular. Have you ever tried to reduce molecular weight of the cytosine? Tried for conventional weight? What we have done, we have used based on ionic G's, we made the dynamic point of view. Nanoparticles. And we measure the size and data of this particle. They comes with an idea 100 to 130 nanometer in size. And they are monolisperse in nature in general. They are we track with the other chemical conjugation and then carry into windows. That is the synthetic molecule. These are like nanoparticles, particles, lighting, and make the particle in one layer. Packaging. That's a particle size. No, actually, I was having a project from far. I was having a project from far, and we used to give 4 gray or 2 gray radiation. That is when you used to break in minor molecules. That is very good activity. Will you be interested? Will you be interested by that? Because that power total change where no, I'm talking about molecular weight pattern. Caption will be like long then you know. Only Sigma, okay, very good. No, thank you. That's what that was. Thank you. Thank you.
Thank you, Professor Kundu, for sharing your knowledge with us. I would request Dr. Himanshu M. Padi, Chairman SGI, to please present the memento to Professor Kundu.
Thank you, Dr. Yeah, sir.
Thank you, sir. We are honored to extend a warm welcome to Dr. Himanshu Mohan Padi, the esteemed founder and chairman of the Sophitorium Group of Institutions and organizer of Nasi INSA conference. With his visionary leadership and dedication to quality education, Dr. Padi has transformed SGI into a leading hub for academic excellence and holistic development in Odisha. Dr. Padi has built an exemplary career education and engineering over the last 25 years. Be, Beginning as an assistant professor, he later ventured into educational entrepreneurship in his late 20s, a field where he has made significant contributions. Dr. Pari is a fellow member of the Institutional for Electrical Engineers India and hold membership in the Institution of Engineers and Institution of Electronics and Telecommunication Engineers India. We are privileged to have him grace this conference, sharing his invaluable insights and experience with us. Please join me in extending a warm welcome to Dr. Padi. So please.
Thank you. Thank you, madam. Esteemed guests, Professor Kundo, Professor Chatterjee, Dr. Saho, Hamida joined us recently, and all my colleagues. Sir, I'll be little different. I was listening since morning, and I was sitting in this conference from the morning, and I was listening a lot of higher band of research in basically life sciences. But basically, my field, as you know, my field is electronics, and we used to deal with many of the engineering experts, and we have many of the R&D projects. But I have limited my slides to only those programs where some community level program we have done, because the theme of this conference is for the science for society. So for the society, whatever the different programs we have done, I will give a little bit insights to this one. And starting with this one, before I go little into this one, I will give a little bit profile about Sophitorium. So this Sophitorium, as we started it in 2007, sir. So we say it Sophitorium. Sophie stands for knowledge, auditorium center. So we mean it knowledge center. So we started in 2007, and we started with in 2007 the Sophitorium Institute of Technology and Life Skills. So we are running a group of institutions, sir. So this Sophitorium Institute of Technology and Life Skills, it's a affiliated institute under Utkal University. Here we offer UG and PG programs in biotechnology, computer science, social work, journalism. So different subjects we have taken up here. Then we started this engineering college, the Sophitorium Engineering College in 2009. Then followed by we have set up a Sophitorium R&D laboratory. We have a Sophitorium public school also. We have a Sophie Skills, one skills training center. We have a Sophitorium Management College. It's autonomous management college, standalone autonomous college, started in 2017. Then we have a Hotel Management and Travel and Tourism Management College. Then we have a Sophitorium Engineering School also. So these are some different institutions we run under this Sophitorium. Yeah. So here, sir, we have about 12 batches of alumni we are having age on that. We have almost 3,000 annual intake in this institute right now into different courses. We have almost 500 plus staff members inside this one, and many more people are staying. So coming to the specific programs, whatever we have done in related to the community programs, one of the program is we did it for some ascent intervention for disaster management. As you know, sir, Odisha is a disaster-prone state, and we face many of the disasters. So we did it in collaboration with this OSTMA. OSTMA is generally they used to fight whenever any kind of disaster it happens in the state. They used to fight the disasters. So we had a long discussions there, and in collaboration with NRSC, National Remote Sensing Center, Department of Space, we took up this project where here we have done a support system during any disaster. Whenever any kind of disaster it happens, then generally the administration sitting, they used to look at for the what are the different resources they are having. Like suppose any fraud it happens somewhere, then they used to look for whatever the different hospitals they are having nearby, whatever the godowns they are having, this police station or whatever it is there, and all other things. So we put all the things on a GIS platform. We develop a mobile app, and on this mobile app, we put it's a GIS based mobile app, and we put it on the GIS platform. So all the resources, so we utilize our student friends. So all the student they put on into this one. So any kind of disaster, wherever it happens, only you need to know the longitude and latitude of that particular place. So whenever you will give the longitude and latitude of that particular place, all the nearby information, nearby hospital, nearby godowns, this, that, whatever the information it is there nearby. Along with that one, within the hospital also, how many number of doctors are there, how many number of beds, these are all the information you can able to get it there. Even we have uploaded some of the photographs. Our students have they did the field visit and they collected all the information of the Puri district. So this all is information, it is rightly available. So any kind of disaster, anytime it happens, only the local admin, they need to identify that particular location. So within that particular location, whatever the resources it is available, at the click of the mouse, they can able to get it. So this is the agreement we got it from NRSC, and it was inaugurated by our honorable chief minister by that time. And so this is one of the activity we did it. This is also, I hope it saves a lot of the community people, direct benefits to the society, and directly relevant to the government. We executed this program. Another program I will tell you, sir, if you are going in and around Khordha, then you must be having some number of crosser units are here in and around. If you will take a 5 kilometer radius of this Sophitorium, you will get a minimum 300 crosser units. I am giving 300 units. 300 units is a very big number. And if you will go to any village, you will find out the people with asthma, with bronchitis problem, this, that, and everything. And it happens only because of the dust. Whatever the dust, the one crosser unit it generates, because of that one, it happens in that way. So we took up this one as a challenge, and we evaluated this one, whatever the crosser units it is there in and around. And then we did a survey. My team, along with my faculty members, they did a survey with some of the thing, and they found out there is ample amount of dust in and around due to this dust, whatever it is generated. Then we found out a solution for developing or utilizing this crosser dust for the construction grade bricks. You must have seen these fly ash bricks are available right now in the different places in commercial mode. So we utilize this crusher dust in that particular bricks, and we tested it into the to the construction grade. So we did some different kind of tests like water absorption test, compressive strength test, efflorescence test. These are whatever the standard test it is required to do the vetting for any kind of bricks for the construction grade bricks. And with the collaboration of CSL Lab, we are having this IMMT here. So we did a collaboration with them, and we get all the bricks, whatever the product. So for the different sampling we did, and we get it certified from this IMMT. And finally, not only these bricks, then again we re-evaluated this one in and around. We have right now we have set up more than 30 cluster units. Inside the cluster units, we have set up some bricks units. And then after we have re-evaluated the cluster pollution there, and now you can see whatever the pollution it was there 5 years back, it has reduced to a larger extent. So this also we re-evaluated, and it is not only bricks. Along with the bricks, we utilize hollow bricks. We train them how to develop the pavers. We have set up a unit inside our campus also, and we made it as a pilot project, and we executed this one. So not only it reduces the pollution of this particular location. Along with this one, this waste is properly utilized, and whatever this product it is utilized for the construction purposes. People are getting livelihood, they are getting income from this one, and it is giving tremendous social impact for this institute also, sir. Similarly, we have adopted some of the different kind of capacity building programs for the community people. We adopted some different kind of capacity building program in different sectors, like in a apparel sector, in a remote electrician, for card-based plumbing sector, LED bulb preparation. So different kind of, with a little bit of intervention of science, we way of beneficiaries. So locally, whatever the natural resources it is available, whatever the kind of livelihood the people they used to do, everything we used to map it on a GIS map, and from that reference we go a little step forward, and from that one we used to conclude the training they need or capacity building program they need to put forward. So likewise, as you see in the likewise, we have a apparel center where we develop some industrial model machines. From the industrial model machines, some card-based machines are also developed. Some of the samples are there in our beside the room. There are some of the labs are also there. Some card-based models are there. So people are being trained up. Many of the people are employed properly, getting benefits out of this one. Similarly, in the plumbing process, generally what happens in the plumbing sector, anybody goes somewhere, they do the bathroom putting and all of the things. Here they used to develop the card training. They used to get a card drawing, and with the drawing, the plumber goes to the bath for the fittings and everything. And the electrician training also, we have this kit with us. Here, the remote based electrician, like here we are having the manual switches and everything. Without switches, we can use a Alexa system. With that command, they can do, or even with your mobile, you can operate. Maybe you have forgotten to switch off your laboratory. You went to your house and you remember you forgot to switch off your laboratories. You can have your mobile. We have developed a mobile app. From the mobile app, sitting at your home, you can switch on, switch off the laboratory, and you can do all these things. So, and some other operations also by using this one. This is widely adopted preparation of LED bulbs at the very ground level for the community level for the ladies. This LED for the consumables, it hardly it costs 20-25 rupees. But the ladies sitting at the home, they can prepare at least 30 LED bulbs in a day. And they used to go to the market, they used to sell, they used to get a very good revenue out of this one. So it's a good community level program you are implementing at the different levels. Apart from this one, we have put on some different kind of clean energy sources, some solar systems in different villages, some subjective for vendors, subject vendors, some additional plant characterization in our laboratory, some different, some basic training purposes, something like that. So in this R&D, under this R&D lab, we have good association. As I told you, from the government of Odisha, we got the funding from Ministry of Science and Technology, Ministry of Education, Ministry of Textiles, Ministry of Skill Development, Ministry of Tourism, Ministry of Culture, Ministry of Space, various MNCs. Sir, being a small institute also, sir, we have very good rapport with different ministries, whatever the programs they are giving. We have successfully, we have executed all the programs, and we got a good name in this one, and we are doing a lot of things, and many of the things related like sensors program and all other things, I have not included because these subjects are beyond the scope of this conference. So these are some of the activities we are doing, and thank you, sir. Thank you very much.
A warm thank you to Dr. Padi for his valuable insights. His leadership in driving scientific and technological advancements are truly commendable. If anybody has any questions, they can ask.
Yeah, I think multiple activities going on
Yeah.
Sapadi, under your leadership.
Right.
I think whatever you are doing, excellent
Thank you, sir.
in these areas. But my experience with KIT University and also KIT Technology Business Incubator, and then all these incubators and incubatees, those who are doing all these startups based on TRLs and everything. So maybe take some initiatives related to artificial intelligence, AI-based approach for that disasters management, healthcare, agriculture, as well as environment related what you are doing. And definitely healthcare related, some of that approach you can also take it along with your ITBI and your other R&D research, what is going on this organization.
Yes, sir. Thank you very much. In fact, She has a program under that one. She had developed a ICD-based healthcare system. That is also one operational model is there with us also. She has this Parimita. She has almost all our faculties. They are having some good programs with them, and they have executed very comfortably, and we are running it smoothly, sir.
Maybe one day we can have one program
Yeah.
where we can bring few faculties from ILS, Niger, IIT, AIMS, KIT, and have some brainstorming. There, your faculties can present maybe 10-15 minutes each along with Dr. Chatterjee. And then we should listen that what is going on by your faculties at Sophitorium. And based on that, we can give some more suggestion and guidance, and especially to develop more and new collaboration. I am happy to see today you sign MOU with IIT
Yeah,
Bhubaneswar.
sir.
And your BPUT Vice Chancellor came, other Vice Chancellor came. So, and today there is no barrier that collaboration between government organization and private organization.
Yes. Yes.
So that barrier is gone. So it all depends on who you are, what kind of research you are doing, whether you are well known in that particular area of research at the national and level as well as globally. So I like that your Vice Chancellor made a BPUT Vice Chancellor made a very nice comment this morning.
Yeah.
That not only by that your IIT, NIT, ISAR, Central University, they are named and framed because of their premier institute and university institute in this country. But now next few decades you will find out from which university or which organizations who is making what kind of product development through Viksit Bharat 2047, through Government of India, multiple program. So, and you can see all awards and everything also now transforming in a different way, including Shanti Swarup Bhatnagar Award and everything. So those who are doing translation research, product-oriented research, that will give a better impact for that organization. And you cannot do 100 different things. My suggestion, and that is the way I followed my earlier organization and also here. I give this message to all 5,000 faculties of KIIT University. You have to have a name and frame based on certain expertise. Certain verticals you have to give importance, whether it's a computer science, whether it's a material science, whether it's a chemical science, medical science, or biological science. So everywhere you cannot be the top. So therefore, you should selectively identify some of the vertical. It can be any areas which is related to the societal impact, and then move it forward. So
Dr.
that's the way.
Padi, please excuse me. Dr. Kundu, Dr. Padi is very smart and very visionary type of person. He has made a new gate, recently inaugurated today. So gate is open for all types of suggestions, all types of collaboration. That is the actually theme behind that. Everybody can come, discuss anything, and develop some good programs. Gate is there, new gate. You can come anytime.
Yes.
Thank
Right.
you.
And thanks to
Correct. Correct. Hmm. 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 No, I know Dr. Chatterjee's activity. I know him more than 30 years, since my Pune Goa days. Uh, huh. But this is same Chatterjee. Huh? So therefore, another area also I noticed that you have very good herbal and traditional plant, all different kind of aromatic plant. So this garden, I want to take it two step further. Can we selectively use those plants, do some literature search? Dr. Amit is also here. He is here. So can we use some of that as a potential drug candidate from those extract, or go for that through the chemistry route, purify some of that, and then use some of that as a potential drug candidate along with the classical drugs what are giving for the treatment in a combination therapy mode, because these are very unique. These plants are very unique. So with a chemistry collaborator, with a bioinformatics, with a life science collaborator, so this is the way I think we have to move. So, mm, yes, 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 correct. KIIT TBI, KIIT TBI. He's talking KIIT TBI. You know that you are also part of that, Dr. Amit. I know you also visited there. I have seen that. Yeah. Yeah. Right. So yeah, not only KIIT TBI, we have a IK Innovation Campus 3 Central Research Park. Now we are having 22nd floor R&D building opposite to KIMS. So now we'll be shifting there. So therefore, you are doing excellent. But I like to see next 5 years and 10 years, short-term and long-term goal. Take certain things in a priority wise and connect some neighboring institute and move next step. And because you need funding. Today, any research, whatever, without good funding is very difficult, especially private sector. I have experienced both government and private. So, and for that, my model, what I showed you, I did not show everything. I showed only 10%. You need to tag right people. Huh? And here people are very positive mind. Huh? People from Niger, people from Niger, Parampur, even the Niger, IIT, AIMS, ILS. These four organizations, it's not difficult at all to connect them, join proposal with Sophitorium, and I am ready to help you. And Dr. Chatterjee is very much knowledgeable what is going on biology, DBT, funding related. I know there is a task force. They provide funding for herbal and traditional medicine, nutraceutical, phytopharmaceutical. And they're starting from chairman and all committee member. I know. So and nowadays it's not difficult at all to submit proposal with a 2 crores, 3 crores rupees. It is few lakhs is not enough. So I like to see that type of approach. You are doing fantastic, but let's move that direction slowly. Right.
Now I would request Professor Anil Chatterjee to please present the memento. Sir, please, memento. जी जी हाँ
It's along with Dr. Amit Ghosh.
yes sir
Dr. Amit Ghosh, because
हाँ
there are momento and then I
yes sir
call him also.
yes
बढ़िया फोटो
Thank you.
Thank you. Thank you very much. Come on.
ये मेरे टेबल
thank you sir. Moving on, it is my privilege to welcome Dr. Pratap Kumar Sahu to this conference, an esteemed associate professor at Niger, Bhubaneswar. Dr. Sahu has made significant contributions to the field of nanofabrication and photonics. His academic journey, marked by his PhD from IIT Kanpur and excellent research comprising of 150 publications, reflects his unwavering dedication to advancing scientific knowledge. Beyond his research, Dr. Sahu's passion for education has profoundly impacted the academic community, inspiring countless students and colleagues. His presence here today is a testament to his commitment to sharing his knowledge with us today. Let us all take this opportunity to learn from his expertise. Please join me in giving him a warm welcome. So, please proceed.
Yeah, thank you for the introduction. Yeah, yeah. Okay, good afternoon, everyone. And yeah, Professor Kundu, Professor Padi, Professor Chatterjee, Professor Ghosh, and other members. Yeah, it is okay. Um, I think I'll not going to present something which is very different whatever you have learned from now, mostly health related issues and presentations. This is something different. I'm a physics background people, so I'll try to make the use of physics for the society. Okay, so I hope I will not give the introduction of neither. I just everybody know, and yeah, yeah, yeah. So this, yes. Yeah. Yes. Okay. Okay. I'll use the down and upper. Okay. So, as you know that now Niger has grown bit larger as compared to the previous sections. We have only four different physics, chemistry, math, and bio. We have four different branches. Now we have introduced earth and planetary science as well as the computer science, which already started. Along with that, we have already humanities present was there, and now medical and radiation physics already started. 3 years back, and one batch already passed out. Now we have a very good center for international science. Okay, where we have all kind of microscopy and imaging facilities. And in the physics, we have now large number of faculties where we introduce that in my group, I work on different kind of nanomaterials for application of anti-reflection coating, for surface plasmon, some magnetic recording, okay, and developing some new kind of materials. And yeah, so this picture I bring here because my site title I give some imitating lotus leaf effect, okay. And if you see that the very interesting this you see the cheetah on cheetah all these dots are in the giraffe all this kind of lines why it is coming up. So it is from the very beginning of my career I started thinking, and whenever I see something I look at the question why it is so. Okay, and for the beginning, for the students, I always ask, unless you start asking questions, okay, you cannot know the new innovations. You cannot think further. So asking question is one of the very important aspects. So that's why when I see some kind of nature like this, what we can do, then this is one of the scientists, and this picture comes from this my lab. When in my lab, I started growing something nickel thin films on bismuth. Okay, and if I put bismuth and grow nickel on the top of it, I have an interface, and on the top you will see a structure like this. And surprising why these structures come, because if I make a thin film, this is a thin film. Okay, it is coated. It is very smooth. But when I go to microscopic view, it look like this. Why it is so? So then it comes to our mind that it takes more than 6 months to find out that what is the reason behind it. Then we come to this picture that Turing is a guy, Alan Turing, and he is one of the very beginning pioneer of AI, okay, artificial intelligence. What he says, like, just solve some differential equations, you can generate any pattern you like. It is very, very simple. I think if, well, of course, there are no students, but still I say that some of the students might be learning from here. That is very simple. All our scientists, whether it is a biologist, chemist, engineers, physicists, everybody know that how the straight line can be made. Y is equal to mx, then this will be a straight line. Now, instead of y is equal to mx, I'll take y is equal to mx square. What shall I do? The straight line will just make a curve. Now, I'll add y is equal to mx plus x square plus x cube. What will happen? Now, instead of this straight line, it will make a completely curve. Okay. And just this imagination, everybody, all the artists make something like this kind of flowers. Okay. Some flowers, then make something like this. Okay. So these are the things coming up. So that means if I take little bit instead of a simple y equal to mx type to faster the differential equation and solve it. Okay. Then all the computer science engineers, they solve the differential equations and write programs. Okay. Then if I solve the differential equation like a reaction diffusion equations, then that means if I have two factors, one is activator, one is inhibitor, that means if I inject something like make a tattoo, I inject some iron-based nanoparticle to my skin, then it make a pattern. Okay. Similarly, if I solve a differential equation and particular type of differential equation, then I will find this can make like this, this can make like this, this can make like this, this can make like this. And same thing happens when on the cheetah, you will find these dots. Same thing happens, the diffusion of one element to the other element to the skin. All the skin's pattern, if you will find, everything is coming from such equations and just solving the differential equations of a innovators. So this is the very fundamental understanding. If the student will learn this fundamental understanding, he can use anywhere he likes. Okay. Doesn't matter whether you go to biology, whether you be a doctor, he become an engineer or he become a scientist. Okay. Yeah. So that is the fundamental things we try to look at why it is happening. So then this is the experiment when we do, and after 6 months I found these things and realized that this is happening like this way. Okay. And this became like a snail structures. Okay. Surface of the snail structures. Okay. This is one of the fundamental aspects we look for. Then coming to the how it is related to hydrophobicity. Okay, hydrophobicity is used for everyday day-to-day life. Now it is like gone up to 100-fold symmetry. Okay, it is like this hydrophobicity is nothing but the fundamental, like if we have a lotus leaf and a drop will be there, it will not be wetted. Okay, so where they will be used? Like in the morning walk we do for the best health, we use barefoot on the grass. In the grass in the morning, the dewdrop is there, and that will be most useful for our health, as well as we understand the physics behind it. So this hydrophobicity nature is basically the lotus leaf effects. Okay. Then we go to the microscopic view. We take this to the SEM and see that the structure is really looking like this. If I take the under the microscope of this butterfly, it look like this. If you go much deeper, you see like this. Then on this kind of structure, I send a light and see in the different angle, I see different colors. That's why the butterflies are beautiful in different colors. If you see in one angle, it looks like reddish. And the same structure we make in our glass. If you buy the Ray-Ban or some glasses and wearing, and you can see everything. But from outside, if it is looking from this angle, it will look red. From this and this angle, it will look blue. Okay, this color are coming from such kind of structures. The internal structure are exactly like this. Okay, so then when you see that if that is the structure, then how do we understand? This is the basic understanding from the 10+2. I think for this audience, it is not required. I will definitely not say or anything. Then most importantly, if we can change this angle, we understand this angle, then we say whether it is hydrophobic or hydrophilic or superhydrophobic. So then how do we do this? Is like whether we can make the wet surface or non-wetting surface. So these are two different scientific languages called Wilson cell or Cassivator state. So in Wilson cell or Cassivator state, it is like something like if I have nails like this, then all the less if the inter distance between two nails it is so small. If I put a water drop, the molecule of the water, the distance between the molecule of a water is approximately 20 to 30 nanometers. If I can make my nails less than that, the water will not go in. Okay, so that is the basic idea. Based on that, this structure has been made so that I can produce something which will be getting wetter, but wet or not. So then this is the basic idea. Then nowadays you are available, you see, you have the shoes nowadays will not be wet at all. Okay, self-cleaning and all these things you see, utensils you nowadays find oil will not be there, is best for our mothers. Okay, in the chemistry and biology lab, everybody use the test tubes. Now you will find all this hydrophobic surface inside. Even if it will not find anything inside, even any chemical it will go because it's a hydrophobic surface. Okay, nothing will be wetted there. So your mobiles, you see that Nokia mobile, even if they give that you throw in your pond, take it out, nothing will happen. These are hydrophobic surfaces. All sorts kind of applications are there. And I had my patent when I was working in Germany that wiperless cars. Volkswagen company, I have a patent in the Volkswagen company. Then we made a glass with super hydrophobicity. As soon as the water drop will fall, within 1 by 1000 seconds, it will go down a meter. So you don't need a wiper at all. Okay, that may take some time to come to India. Okay, very high-end cars are there. Till now in India also you will find wiperless things. So nowadays these are typical applications. So we look for the fundamental how to make such kind of structures. Okay, so this is one aspect to work. Another aspect is like plasmonics. It's very interesting. The same structure we can make, but it works as a plasmonic. How does plasmonic? It has enhanced, like surface tension Raman spectroscopy and other things. If you see from the glass, if you look from the outside, it will look green. If you look from the inside, it will look red. The colors are very, very different only because of the nanoparticle of the gold. And the same nanoparticle we make. And this is another patent. When I was working in PSI, also the institute, this is a company called Shiba. And we have make an array of nanoparticle of gold. Then it is used for diabetes patients for their testing. Okay. And nowadays in India, if you buy a strip, I use it and throw it. Of course, the cost is go down. But if you go to Switzerland, you buy a strip for one person, you can use 100 times. Because we have a series of lines, okay? And I think in the next slide, we have that how we make it. Then we make this and tested in the lab that we take any kind of DNA or molecules, take 20 nanometer of gold, very small gold nanoparticles, make an array and dot of these antiparticles, and there's a gold nanoparticles. Then we put our DNA or RNA on top of it. Then we sense it. So then glucose sensing is like if you put less than 1 microliter or nanoliter of blood, then it will go to the first array. Second array will not be affected at all because this less than 1 nanometer or nanoliter of this blood, okay, sugar, that size is exactly matching with the one line satellite. When you put the next one, you don't have to throw it. You use the same one, it will go to the next line. Like the similar way, you can use 100 times, more than 100 times. We have tested 150, 100, 200 times, but company selling in the name of 100 times. Okay, so the same thing is available in the market. Okay, that was one of my patent we work. And the principle is very, very simple. The principle is like if I have a gold nanoparticle like this, I get a spectra like this. This is extinction spectrum. We take a spectroscopic view, then I have basically the UV visible spectroscopy. Okay, this is all the lab has. Then, as soon as this molecule or this RNA or DNA or whatever your this glucose molecule will sit on it, then as soon as this potential or this you can say the refractive index changes, then this will shift. The shift, we have a marker. From the marker, how much shift will say that what kind of molecule is there. Whether it is DNA, whether it is RGA, whether it is CDG, all any kind of molecules. I can identify without giving me the references. Okay, this is one of the sensing capacity of this gold nanoparticle arrays. So then these are the particles we study and do the physics behind it, look for the applications, and then do the simulations. And we see that the simulation we have done and tested that is very, very simple. This is called lightning effects. Lightning effect means if I put my light torch, okay, it will diverge. Okay, can I make a lens where that instead of diverging, I will focus it? And the focus on the top of this light is extremely high. Whatever my initial intensity, in the top of this, the intensity will be 10 times or 100 times higher. So if I am getting the input light to output is much, much higher, that is basically called the lightning effect. And this lightning effect enhances my sensitivity. Okay, that means even if less than a nanometers, we can sense. If the molecule size is close to nanometer or an angstrom, okay, few angstroms, then that can be sensors. Sensing can be done. So this is very, very useful. Okay. And then we do this, and this is the simulation final. And this is one of the during 2010, and this is one of the best sensor in the market. Okay. ETH Zurich, I work in the close collaboration with the ETH Zurich in Switzerland. This was the best sensor in the market. Okay. That we have developed in our lab. Okay. Then this is the test and all these things using Sophitorium essay. And okay, these are the data for that. Okay. Then importantly, how do we make this kind of structures? Okay. The structure we made in laser interference lithography, we have a setup, many different kind of lithography in our lab now here. Okay. So we can create structure like this. These are different principles: two beam interference lithography, multiple interference lithography, pinhole lithography, achromatic Talbot effect. So many effects are there. So we use these techniques and we can create 20 nanometer line shape, 16 nanometer line shape. Can you imagine? The line between two is only 16 nanometers. Okay, so small. And this is one of the things we have used as this is the best application for geography. Like during that time, even in 2008-9, okay, this has developed, okay, in ETH Zurich, and we use this for the xerography. That means now if you go to the local market and make a Xerox, it is very heavy. It will not a very good quality. If you have a very good Xerox machine, and if you make a Xerox, it is quality is extremely high resolution. Very even exactly things, even a small dot somewhere can get it. Okay, this xerography development happens only from this kind of line structures. Okay, the machine this is silicon chip we are using has inside this kind of lines are there. From there it comes. Okay, that is the internal structures of any kind of 3D black material. So these are the steps. If we go down to lot down periodicity, and we work here, and this is the same thing. If you instead of a gold dot array, if you have a nickel dot array, it will high density storage. So these are used for our pen drive, like one pen drive now 1 terabyte, 2 terabyte coming in a small pen drive, and it has increased a lot because of this kind of structures. Okay, so then these hydrophobicity things, like I promised that I'll tell you about how the hydrophobicity helps. Okay, for the society, it is like if I take a materials and deposit the gold, like our inks. Okay, and you see the luster has gone down. Okay, the sign of this gold after a few years go down. Why? Because if you look microscopic, okay, this is only 200 nanometers. Within 200 nanometers, so many like this kind of dot structure. This is not filled at all. Okay, it's not a smooth surface at all. Even if it is 100 nanometer gold. Okay, so this is after certain use. Okay, the dust, then water molecules, so many things you are using actually working. So things will go down. Then the sign is going down. Okay, this is a very standard technique. This is the region. If my thickness is different, and you go to the goldsmith market, you will find that gold is sometimes purely yellow, less yellow, red yellow. All these things coming up. How many thicknesses are there in your gold? That is the basic microscopic principle, I'll say. Then we try to make it and do annealing, and in the furnace. Within the furnace, I found out we can make a structure like different kind of nanorods. Like I told you, in the nail or a particle, distance between two particles is matter whether it will be weighted or not weighted, deviating or non-deviating. So this is the how we make in our lab and make such kind of nanostructures. Okay, which is basically this is on the glass, which on the wipering screen. Okay, this is on the glass substrate look like this, and this is on the silicon substrate on the chips. Okay, all this we use, and this is used in the furnace. This is used another way is the ion beam techniques. So this is one of my lab at Niger. We have a particle accelerator. We can create any kind of ions from hydrogen to gold, silver, any kind of particles. And this ion beam can give you the different techniques where you can make such kind of nanostructures. Okay, this is the principle. Then you see, if I take a silicon only or silicon oxide, implant some xenon like some kind of materials, some kind of ions, 1 into 16, nothing happens. But as soon as I give a gold layer on top of it, I show already how the good layer look like. Okay, Then after this irradiation, it become dots. Okay. How it happens, everything I have explained, but I think for this audience is not required. Then we create the nanodot size and the distribution of the size. Okay. And the particle size. All these things I create in such a way that whatever the way I want, I can do it. So then I look and the different things. Then I look what is the typical particle size and everything I can distribute. Now I have a map. If I want this particle this side, this particle this side, I can make it. So this I have done. Okay. After that, what I do, I try to understand the physics behind it. What is the sputtering, how the irradiation happens, how recoil happens, everything. Then if I put a light on it, how the color changes, different colors can be assigned. So that physics we do. Then finally look for the hydrophobicity. Then from the beginning I told, depending on the angle, I can say it's hydrophobic or super hydrophobic. Then I see if it is way above 90 degree, then it's super hydrophobicity. Then it goes to a classification step. That means it will not be wetted. So such kind of structure, if I make, I put it on here, let it slanted, put on the water, it will not be wetted. In a fraction time, it will go down. Okay, that we have tested, and this is called hydrophobicity, or this is basically called lotus leaf effect, which is basically used for many, many ways to our society. Okay, so with this, I thanks. This is my summary, and all the credit goes to my student, all the old students. I have nearly 10 students have gone from my lab. Now another 5, 6 are working. There's some master students, some postdocs, and my collaborators from different places, IOP, IOC, and my in-house collaborators. With this, thanks for your attention.
We deeply appreciate the time that you have taken out to be here with us today. Any questions, anyone? Okay, Professor Kundu, sir.
It's a very interesting area. So I have couple of questions. Other day, Director IMMT was giving talk in Odisha Chemical Society conference at our university, and I was chairing his session. Dr. Ramanuj Narayan, current director IMT. So he works on coating chemistry, use nano material science, right? All different kind for nail, for lipstick, for many other coating related, and in a specialized way, an application of material science. So here that some of your approach, that lotus derived and all those. So you said that if like a windshield car, so you don't need there is no accumulation of water, it will be automatically just clean. What happened country like USA, America, they have huge problem winter time because of frozen ice. Uh, so can you, my question to you, can you use any anti-freezing agent along with that? And is it possible to make a coating in this automobile car's windshield or something? Because they spend huge, when they morning they go to their parking lot and use their car and to start it going to office. They have accumulated like a 4-inch, 6-inch chest frozen snow. Mm, 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 mm. Right, right. Mm, mm, mm. Right. Mm,
this graph I'm getting out there. Now that almost all their text, they're reading the same task. Because they are done, they don't even need us. They're reading them to something. That's what we can be reading that. And in that, need to be done. It's a very easy for
Okay, so I have another quick question. With your this expertise, now again I am very closely associated with a School of Dental Science of KIT called KIDS, along with their principal, and they have a 70 to 80 faculty, and they are doing a lot of dental research. So my question, specific question to you, now the dental industry also coming major way, not only changing that material for root canal therapy, but many women and ladies and even males and everybody cosmetically they want to polish their tooth. So like it's totally changed. So like once in a year, twice in a year. Can some of your application can be used for coating of that?
this operator, others operate with data. That is, with the mental, yeah, long that how the data you can.
Right. But I am simply saying I am not talking about laser based. I am saying that like polishing and coating and polishing because this is a huge business now.
Making the link and for that.
Correct. Right.
Instead of like these
Correct.
and the light and the semester, don't tighten and first year.
Correct.
These are the new actor development.
Right.
I have a polarized letting of the and what.
So if you are interested, I can connect you through that KIDS dental science. Thank you.
I would now request Professor Gopal Sikundu, convener of INSA Bhubaneswar chapter, secretary, and director R&D KIIT University, to please present the moment. Okay, I would request Professor S.K. Acharya, CEO of ITBI at Sophitorium, to please present the memento. I extend a warm welcome to Professor Amit Ghosh, a distinguished academic and researcher from the Department of Physiology at AIIMS Bhubaneswar. Professor Ghosh's contribution to medical education and innovation have significantly advanced our understanding of physiological sciences and translational medicine. With a strong focus on cutting edge research projects such as clinical validation of organotropic tissue slices, and 3D organoid models for cancer drug screening, Professor Ghosh has integrated basic sciences and clinical application. As we gather here today to share knowledge and explore new ideas, we are excited to have him enrich our discussion with his expertise and insights. Let us warmly welcome him as we look forward to learning from his valuable perspectives. So, please.
So, very good afternoon. I convey my sincere thanks to Dr. Gopal Kundu, Dr. M.N. Pardi, and Dr. Anil Chatterjee to give me the opportunity to present here. And so I'm going to present this kind of overall approach because the topic says virgin coconut oil as a source of potential anti-cancer agent. So basically, actually, the project was funded by the Coconut Development Board, and they are trying to means increase the market of this product and to develop different product from this coconut development boards, coconut type of means coconut oil and other things. So they fund this project. So before that, I did some small market research. That is that the India is the third highest production of the virgin coconut oil. It is virgin coconut oil is different from coconut oil because they approved on 13 October 31st, 2006. That name is Verigen. Basically, is a sign catechin is a green tea extract that used for the treatment of the genital wart. So, it the approval of FDA and industry get a framework for bringing other botanical drug in the market, and followed by different botanical drug come like symptomatic release of non-infectious diarrhea in adult patient with HIV for retroviral therapy. Another drug come another drug come treatment for the glass pollen induced allergy. All are botanical drug. It is not a made of single molecule. It is a combination of molecules, but going through the same procedure, rigorous procedure for the approval. So so it get the FDA approval. So then I tried to find out that our objective was to make some product out of the virgin coconut oil or export some medicinal property of the virgin coconut oil. So we find the literature search and really 1987, 2017, most of the review, but few are also published work that mainly in the in vitro model, cell culture model, it shows that the virgin coconut oil shows the anti-cancer activity to trigger apoptosis and maybe that in cell, cell death in lung cancer cell, uh, breast cancer cell. So different cell lines they can trigger that. So it has the anti-cancer property. So first, to find out this, the major uh, fatty acid which present in the coconut oil is the lauric acid. It is a 50% of the fatty acid of the lauric acid, followed by myristic acid, caprylic acid. So that time there is almost no publication when I started in 2015-16. And what is the uh, you know direct role of this acid anti-cancer role? So I did some comparative toxigenic database. I find out whether this drug indirectly or directly, these molecules, means fatty acid indirectly, directly has some role with the disease, and find that inferred association, not direct association, that lauric acid, uh, both caprylic acid and myristic acid has association with cancer, right? So means not cancer causing, maybe cancer prevention. So that is kind of indirectly, means whatever data available in the net, based on that indirectly we curate this data. So now come to that. So for virgin coconut oil, I what I did, that my objective was to test the compound of this linoleic acid, caprylic acid, and myristic acid, is role in anti-cancer role, as well as because I want to bring it as a form of, because I cannot use, if my mind was that I always bring in trial, so I cannot use the separate compound. When I use separate compound, my ethical committee will not allow. So what I did to find out that what is the whether which fatty acid has a role in the responsible for the anti-cancer property of the virgin coconut oil. So we fractionated the coconut oil in different way. So where we got the collect the three fraction, the virgin coconut oil, processed coconut oil, fractionated coconut oil, where that we able to enrich the separate portion. We bring for the market, and here you see C12 and C14 is the predominant, that is linoleic myristic acid. Here, sorry, here caprylic acid is predominant processed, and here linoleic acid, oleic acid, long chain fatty acid is predominant. So after fractionation, I thought I'll get some activity, anti-cancer activity. So I buy this oil, fractionated oil, and we test that composition by GC chromatography. Dr. S.N. Nayak from the Delhi IRT Center for Rural Development and Technology, he helped me to test this. We test the composition. So we test this three fraction in the cancer cell line. And previously we try both mouth cancer cell line and liver cancer cell line, because I can use it for as a mouth, and it can be as is a fatty acid. By total circulation, it directly can reach the liver. So I thought if I use, he can use as a mouth coating, or liver treatment for the liver, some liver cancer, or maybe topical use for the. So anyway, then I test this in two type of cell line: FG2, which is liver cancer cell line, and KB cell line, oral cancer cell line. And I see the potentiality. I expect that this three fraction will show that different type of cancer activity, or maybe some fraction will show that cancer activity, some fraction will not show. So based on that, we can pick up that which fractionated oil has the anti-cancer activity. So we see that VCO, virgin coconut oil, and 20% concentration that triggered the anti-cancer activity in both cells, FG to KB cell. Processed coconut oil, which is caprylic and caprylic acid, is predominant. They triggered anti-cancer activity 20% in KB cell, oral cancer cell, but 80% in FG2 cell. And fractionated coconut oil, who has mainly the long chain fatty acids predominant, in 5%, they triggered the cell death, significant cell death in KB cell, oral cancer cell line. So, but long-term fatty acids is very less in coconut oil, so I did not process with that. I proceed with these two, the virgin coconut oil and processed coconut oil. Sorry. So based on that, first to start the trial, I have to generate some data. What is the evidence behind that? So I developed a screening system, where microRNA based screening system. In this screening system, I use two groups of microRNA. One is oncogenic, and tumor suppression. Oncogenic microRNA is those microRNA that upregulate in cancer, during cancer, and tumor suppression is those kind of microRNA that downregulate in cancer. So I use this two group of microRNA, see that this linoleic acid, which is the main fatty acid of the coconut oil, how they regulate these things. And my another objective was to develop some screening platform based on the expression of oncomet at tumor suppression. So then I can screen the anti-cancer molecules. So based on these two objectives, I try this. And for I pick up this microRNA, tumor suppression microRNA, and lauric acid, sorry, oncogenic microRNA, so that can hit the different domain of this, like metastasis, inflammation, angiogenesis, migration, invasion, apoptosis, proliferation, initiation of tumor. So different domain of the cancer they regulate. My objective is that to test this, that if I see the expression of this microRNA, so I can assess the molecule which affect which domain, either it apoptosis, or they prevent invasion, angiogenesis, or they prevent metastasis, and whether these molecules can change the balance, means decrease the oncogenic RNA expression and lauric acid, and sorry, increase the tumor suppression microRNA expression. They can restore the microRNA expression. That way they can. So that way we pick up this two group of microRNA and we test in the cell line, and we see the expression of this microRNA in presence of the VCO and PCO, and sorry, in presence of lauric acid. In Hep2 cell, you see that is the we find that this microRNA, that mainly the MIR 22221. So basically, I'm telling you microRNA what they do. They generally bind with the UTR region of the mRNA, and they degrade the mRNA. So it kind of process, they downregulate the mRNA. So that way microRNA work. So you see that is all there are oncogenic microRNA. They able to downregulate. This is a control, and able to downregulate the couple of microRNA. And this is a tumor suppression. They able to which decrease in the tumor, but they able to upregulate the couple of microRNA here, like mid LET7, mid 16, mid 29, mid 985, and few of them are already in the trial also. So same thing I try in KB cell also. KB cell they were to also increase the decrease the some oncogenic. Oncogenic means, as I told you, that it expression increase during cancer, so it able to decrease, and they able to upregulate some tumor suppressor, which usually decrease in cancer. So that way they able to restore the tumor suppression oncogenic expression, and they can do. So then I try to find out through which pathway they may work. Then I find out the two molecules, one molecule, two cell line. I found that they are consistently regulating the mid 16, mid 21 in KB and Hep0 cell line. So then I will later go through this further, see the mechanism of action, how they do. So this is a bioinformatics application. So almost they hit different pathway. You see that mainly that DNA damage response, stem cell differentiation. So different pathway they are hitting. So it gives their mechanism of action. And here also the two group of, this is the KB cell, this is a liver cancer cell line, this is a liver cancer cell line, this is a oral cancer cell line. In two cell lines, they downregulate this three consistently downregulate three microRNA, mid 21, mid 17, mid 28. So that means they consistently downregulate these three microRNA, so they have some common mechanism. So I did not, for mechanism of action, I did different experiment. I'm not going here. So based on that, I find that which pathway may be affected through this microRNA. So that give me the idea. Okay, this lauric acid is a the main component, which is the coconut oil, virgin coconut oil, almost 50%. They can have the anti-cancer potential. Even human beings has a lot of lauric acid also, and lauric acid is less toxic to the body. There has no toxicity in the body, and and the VCO and PCO, we used to take it when south they take it as oil. So I can use it so that it will not be prevented by it will not, there is no objection will be received by the uh, Institute Ethics Committee. So then I designed another experiment for efficacy of virgin coconut oil in preventing oral cancer in the patient with an oral pre-manipulation. As you know, OPL, the submucosal fibrosis, erythroplakia, leukoplakia is very predominant in India. So generally, for if someone detected, it has no treatment. Their standard treatment is their prescribe some antioxidant capsule, mouth opening exercise, that's it, and follow up. So that has a huge potential basically nothing to nothing. No medicine is there for the treatment of oral pigmentation. So I think there is a gap and he has a market potential. So I thought that let's see whether the VCO and lauric acid can test it for this. So I start to conduct a trial. The objective of the study is to test whether VCO may help reversing the oral pigmentation lesion to normal and thereby preventing the development of the oral cancer. The primary objective was to determine the clinical response of the oral pigmentation lesion to 12 weeks of VCO intervention and histologic response of the VCO intervention in the target lesion. There is a overall design of the study. Case standard treatment plus virgin coconut oil as a mouth coating we use 3-4 times, 4 times, and it is the only control treatment. Sorry, standard treatment. So we did the 0 day when the biopsy we detect. We did immunohistochemistry for KI67P53 clinical screening, and they visit again 12 weeks and 24 weeks. And here also in standard treatment also do the same thing. And based on this follow-up, the study is now going on. So based on the result, maybe we'll think later the what kind of do that. Another thing is mechanism of action. I'm not going there, mechanism of action. So that is
Thank you, Professor Amit Ghosh, for your valuable contribution today. The panel is open for any questions.
Yeah, it's a very nice talk. So I have two specific questions. Number one, this virgin coconut oil you are using for the patients who develop HNOSCC patient. So my question here, who develop pre-malignant? Right. Okay. Okay. So my question is a little different. My question is, what is the active component which is present in the virgin coconut oil, which is helping for the control of this? Correct. Correct. So that correct. Long chain fatty acid. Correct. Second quick question. What is the absorption capacity of this oil? Because oil usually they don't absorb much. Your leopathy and all those, it happen in the different patches there. Because if you maybe tag with some nano formulation to increase that absorption capacity of this oil. Mm. Right. Because these type of patients, when they develop pre-malignant to malignant, there are specific enzyme like N-acetyl neuraminidase and all sialidase. They express more because they have a sialic acid branching. So Maybe that way you find out that what is your active component, what kind of fatty acid. Mm. Right. And second, last quick question, microRNA related. You know, many of that miRNA now they are acting as a early detection signature and biomarker for detection of cancer, especially from CTC, circulating tumor cells. So that is coming in major way. Do you have any plan to move that direction? For this detection of the filter already built on it. So something more than yes, sir. I know it was biopsy and yes. From that, we it used to use to find out the one the origin of the virus. From that, so you will tell you if you are monitoring this or the possible action. So, I'm looking for that because maybe you can't the find out. Like what are the that's necessary for a law, not only very correct. Reality, right? Keep it about. You have good patients. Yes, very good. You have a yes, patient. Yes, what has the correct coming to your mind? Other people who are who already able to know their life is not that complicated. How we find out find what what. And it's not thank you.
I request Professor B.K. Mishra, Professor at Computer Science Department of Sophitorium, to please present the memento to Professor Ghosh.
Right. Right.
Sir, please, small potted plant, please present. Thank you, sir.
Thank you. Before Madam proceeds further, I have a request for Dr. Chatterjee. Sir, people are ready. That's it for Sophie Fest cultural evening. Let's enjoy also the evening. So please quickly finish your presentation. Yeah.
So there is a special award you will be getting shortest stock.
I welcome.
Thank you very much, Dr. Padi and Dr. Kundu, to put me on as the last batsman in this whole evening. Uh, I always confess that I'm not a successful scientist, first thing. But my failures are my experiences, which I would like to share with you. See, actually, I was working with the Prime Minister's office, and I was coordinator for Indo-US and Indo-Russian program for oceanology. So I was invited to CDRI along with the scientific advisor to Prime Minister. And we were having some discussion, and Prime Minister was seeing some of the things. And one girl, Dr. Gundu, she from CDRI, she started telling, sir, I have published 2 papers in Nature. And these are my very good papers. So Prime Minister, Honorable Prime Minister told Dr. Harshvardhan, सर देखिए ये 2 पर्चे इसने छापे हैं नेचर में So Dr. Harshvardhan told what exactly society will get. So what society will get, these are the basic research. And it was a very embracing position for me also to actually reply to that question. Here I am not going to discuss anything about very high class science, but whatever science that we did, for the society, I would like to share with you. See, normally people they think that science and society, these are two components, different components. But we all scientists, we are from the society only. We start thinking out of the boxes. That is why we develop sciences. Okay, quickly I'll go and finish my this thing. And between society and science, there is also one component which is known as innovation, industry. So whatever we should do, it should be translated to industry. It should be utilized to the industry. I'll give you some examples in my slide. So good science is problem selection. We should always go for selecting a correct problem which is required by the society, not required for my promotion and not required by any other thing. A smart objective, proper methodology, proper analysis, fair subject selection, favorable risk benefit, independent review, and informed consent. See, this is the best example in my life. This is the best award I got in my life. There was a science congress in Goa where children below 10th standard they came and they presented their projects. One boy from West Bengal, he was not able to speak English or Hindi, Bengali. So I was selected as judge. So my Bengali is very, very poor, but I was the judge. That boy, actually, this is the best example of the science, Kundu Sahab. And I will tell you the afterward. That boy, in that small village, there was a water scarcity. And that boy went and saw that water and the water is available or not. He found actually there was a overhead tank. Water was in great supply. Even then, people were not getting the water. So then he said, "What is the problem actually? Why people are not getting the water?" So if you see the first slide, the taps were made with the brass. So people they used to come and they used to fill the tap. Okay, so water was flowing without the taps like this. Okay, so what he did, he went to a carpenter, made small plugs like this, and put it in the this thing with a hole and a note. After collecting the water, please put back this plug. I selected first. So there was a duty of the judge. There was all judges should come and tell the committee why I selected this boy for the best award, DST best award. I said this boy. First, he identified the social problem, why water was not available. Then he identified the resources. Resources were enough. Then he identified the problem. What is the problem? And he identified the solution also. This is the solution, which is very, very, very cheap. The boy got first prize. I got first prize as a judge. And that is the award, I'll tell you, I'll share you. That boy, DST actually supported him to do PhD free of cost. He went to USA and after 22 years, 4 months before, he was calling from NASA. Sir, I am Alok Mandal. I said, who is Alok Mandal? Sir, you selected me for the best award for this DST, this program, Science Congress. Now I'm working with this NASA. That is the best award in my life. And I was so happy I started crying. Okay. See, necessity is the mother of invention. And even if you go to villages, frugal technology, जुगाड़ जिसे बोलते हैं ना, जुगाड़ technology. So if you go, see this gentleman, how he has developed this technology. This is the another technology he has developed. This is the another technology he has developed. And the best is this one. Okay. Necessity is there, but there is no repeatability. Large scale people will not accept. Science should be like that many people they should accept. Mass acceptance of this technology. So this is one thing. This is a fantastic example, Dr. Kundu. Afterward, Dr. Kundu will realize. See, in Goa, this particular animal is there, which is known as green mussel. And people, they eat green mussel, delicacy of Goa. And we are exporting tons of green mussel from Goa. You know, few years before, there was no availability of this green mussel. So how to address this problem? No green mussels. Immediately, Goa government contacted us. I was the project leader for this. So I have developed a technology to collect the seeds and grow like this. All ladies were involved. See, that one is my institute. This is my institute. And we have developed an off-bottom mussel culture technology in Goa, which was actually giving lot of revenue to local fishermen. And this is the underwater photograph. These mussels, tons of mussels. Whole Goa was full of mussels. And this technology was sent to Russians, and Russian came to see this one. Then the Russians invited us, and the whole story started Kundusav after that. So whatever, a successful linkage program. I'm sorry, I'm using some bad words. Bad word means most of the technologies, good technologies are developed with the glass of beer. So I was having beer with the renowned scientists at Habitat Center, uh, the Delhi. Sir, this was the example, in the history of the science, Dr. Padi. I was having beer with one scientist, and Dr. Mashilkar, who was Director General of CSIR, he also came and said, could you kindly allow me to join? I said, yes. So as he asked me, why you came here? I said, I came here to give a presentation to take some funding from DST under Indo-Russian Collaboration in Oceanology program. How much is your budget? 80 lakhs. 80 lakhs. You are going to address so many problems with 80 lakhs. I said, but tell me how much money you want? I said, if you are allowing me, give me 5 crore. Given. This is the one example in whole CSI history where not a single project was submitted to CSR for funding, and next day I got a check of 5 crores. समझ गए जो whatever we did along with your institution, no, that was because of that, because we were having that vision, we'll achieve. Then what he said, after how many months are you going to return back the money? I said, within 6 months we'll return back to you 2 crores. How? So my director came. By that time, Dr. Disa was there. He came. What do you want to tell you? So Dr. Mashal asked me, how many glasses of beer you took? I said, I had not yet started. So then he said, okay, come tomorrow, take 5 crores. I went to NCCS Pune, and I started developing program with 5 scientists of his institution, 2 scientists of AIMS Delhi, 3 programs with ICGB, and 1 program with IIT Kanpur. Okay. So, and my role was to collect the animals, prepare the extraction, and characterization. ICGB, anti-malaria, Gemini virus, and dendritic cells. See, the approach is like that, whatever conventional drugs are available for malaria. So, what would be the new thing? Suppose I develop. So, new thing, like chloroquine and other drugs, they are having a particular target. So, they work on that target only, or before that stages, sometimes they develop resistance. That's why chloroquine resistance is strain. Okay. We have developed which can kill all the 4 stages of malaria parasite. That was the biggest success in our life. We got 2 crores for selling this molecule. I gave it to CSIR. Take this 2 crore. And then from that day, we started our new research. The other was NCCS Pune, osteoporosis, anti-HIV, and leukemia inhibitory factor. See, this was the fantastic research which his group, Dr. Kundu, Dr. Vani, osteoporosis. You know osteoporosis. formation of the pores on the bones. Okay. So normally it happens in female. Why female? Because there are two types of cells. Okay. Osteoclast and osteoblast cells. Osteoblast cells are responsible for bone formation, and osteoclast cells, they keep on eating the bone. On osteoblast cells, the activity is controlled by the estrogen. Estrogen is produced by the ovary. And once the ovary become defunct, especially after menopause, estrogen secretion will not there, osteoblast activity will not there, and always there will be formation of the pores on the bone. Instead of developing a drug, what we did, we actually developed a technology by which the osteoclast activity stopped. So there will not be any bone, porosity on the bone. This also patent we got. This is bone resorption. See, this is the bone and the bone resorption. Then HIV also we did some work with the Dr. Mitra. Then AIMS anti-tuberculosis, Dr. Sarman Singh. Then IIT, whatever molecules we have developed, Professor Vinod Singh, he synthesized all the molecules for us. This is the structural formula of the molecule. I was having actually a program with Pesticides Institute, Russia. So I used to go to Russia and I used to work with them. There was a big problem in Goa few years before, and I was actually approached by Goa government. There is a special type of bivalve cell which is known as window pan oyster. During Portuguese time, they used to collect the animal, and these are the shell of that animal, and they make all this type of chandeliers and other thing. Even window they are using. Completely population vanished. So whatever cottage industries were there, they were closed. Local fishermen, they were not having any livelihood. So I did a very small attempt. Very small attempt means that's why I'm telling you must know the actual what is the problem, why these things are not happening. So what I found that after the monsoon, during low tide, ladies they go and collect the animal. And after the monsoon, that is the breeding season of this animal. They collect all the brooders. So if you collect all the brooders, population will go down. So what I told, don't collect animals during 3 months. They didn't collect, population restored. Many industries, they already started there. Okay, cottage industry. So it's very, very simple. You should know actually where is the problem, how to solve it. Big research, we can solve many problems. But immediate problems is like that. Animal is not there, no livelihood, no industry, nothing will be, growing. And sometimes when you grow this window pine oyster, you will get good qualities of pearls. Sometimes 15,000, 20,000 rupees a pearl. Very, very precious pearl. Now we have planned very small project with Sophitorium to extract curcumin. I am actually a scientific advisor to one private company, Indo-Vedic. They want curcumin as well as turmeric in tons. It's a very funny thing. If you collect curcumin from turmeric from Kurda, curcumin from this place, curcumin from Meghalaya, curcumin from Sangli, Maharashtra, the yield of the curcumin will be different. Okay. So what actually we will be having two approaches. So the uses of curcumin, there are many uses. There will be two approaches. How to simulate the condition of Meghalaya or Sangli and produce the turmeric in Odisha. That is the first approach. Second approach will be, can we increase the yield of the curcumin by using the local variety? And you will be pleased to know, Padisam, we started working on that, and you can see how much curcumin is there. There just 4 or 5 days before we did this experiment. All fluorescent curcumin is there. Now, the approach will be like that. We will pass on this technology to local farmers to simulate those conditions to grow turmeric, any type of turmeric, whether they are giving 2%. Dr. Kundu, the type of turmeric, which is giving 2% yield, the cost is 120 rupees per kg. And the type of turmeric giving 8 or 9% curcumin, cost is 500 rupees. I am claiming 12%. I am claiming I will go up to 12%. So if the person is here, Khurda Road, he is growing turmeric, and then first step, this thing processing will do, and then we'll sell the, how much money he will get, the farmer. So this is going to be another program. It's a very small program. I don't claim that it's going to be big, but it's going to be very big because the requirement is very high. Presently, we are supplying in global market 80 tons curcumin, most of from India. We are targeting by 2026, 280 tons curcumin will be required. From where will meet this demand? Okay, so we are going to do that thing.
How we are increasing the yield?
That is the patent. Ah,
The reason I'm asking, we have a project, nanoparticles.
mm,
It is working on so
mm,
limiting turmeric desalination. CRY conversation and to across the country. So the idea was whether we can have a uniform curriculum with the same composition and everything and their quality. That's where various of this sector. And because it works in malaria, it works in cancer, it works in
yeah, the most importantly, just
and through that
this is the most important thing, issue in
it will be that.
See, I tell you, I'm not disclosing because I have a maybe problem. Next week I'm going to file engineering, and then I'll let you know. See, I was CEO that I was associated with one big company, Yashar Biotech, as a CEO. Okay. So what actually we used to collect cancer fluids, we used to isolate the cancer. He was about 60%. He made some attempt and he became 20. How? Same way, we are going to use uh, turmeric, first step processing, and then start the process of isolating, extracting globulins. That process is patented. As you know, I'm going to write many globulins.
We extend one step further. If you want that nano, like a cytosine nanoparticle, so we are very good that our team, we have a strategy and the product is ready.
We will certainly go for that. Actually, the demand for high yielding turmeric as well as curcumin is very high. This company, innovative company, today, if suppose I want to say 50 to 70 tons of turmeric, they are ready to buy. Provided they should have yield of 5 to 6%.
So out of the other two company, one in Ahmedabad, one in the Cochin area, we are also making curcumin.
Many companies are there. Why not absolutely? I'm telling you, many companies are there. My approach is to support this local farmers to grow the turmeric. My approach will be to give a technology to Sophitorium where can they bring the turmeric, they can go for one step processing at their place and sell it. Nothing else.
Very good.
Huh?
Very good.
No complication, no complication. So what actually society needs, water, quality water for drinking, availability of then sufficient water for irrigation, quality food, and health sector. So basically, we all are working for health sector only. So also want to come out with something. So thank you very much. I hope I will take my time. No, sir. I didn't for you to know. No, sir. I will not actually. Excellent presentation. Party had to party was touching my presentation thinking we very good in that. And similarly I did my question. So I don't believe in No, I started not believing on high class science. No,
That I have seen. I have seen your entire journey.
science, very simple science.
30 to 40 years.
Yeah.
30 to 40 years I have seen you.
Thank you for your argument, right? I'm still happy.
Very happy. Very.
Thank you very much.
Thank you, sir.
Yeah. So, yes.
That is actually product development is not science, product development is art. How you assemble it? How you find your problem like that?
No, see, but they have to find a problem. Yes, exactly. I'm telling you a very, very cool thing. Then Sardaki के घोड़े में बाहर में शॉप फॉलो कॉपरेटिव का पार्टी है ना हमारे शहर में ऐसे हम देखे हुए हैं अरे our time is like that industry come forward आपसे छोटे रिलेशन प्रॉब्लम है हम अपनी पास से जाके के घोड़े में घोड़े काम कर रहे हैं हमारे में डाउन मैं can do not get any science so our science should be only dependent on the need of this time. But society we right, we are not dependent on society. I told Dr. Ashwada that we are not dependent. Only our team is slightly off the box. Only nothing else.
No, sir, I am really extremely happy. We are in searching for since long. Uh, Sir, we have a very small tribal place nearby, and we adopted that place. And within that one, I have a farmhouse here. And I requested him so many times, "Yes, sir, let us do something for that community people. And whenever you are coming, sir, you must have seen there is a big Borune hills in there. And there are plenty of hills, plenty of horse it is available. So in my that farmhouse, as per his suggestion only, maybe some 2, 3 years back, we put on some settling of the plants and we developed that. I requested him, sir, do something for the community people. So repeatedly I requested. So on Sunday he started the what your people can do. Then we started exploring. But he has got up to so much extent I didn't know.
Sir, I'm very good that this window and other was the direction. So,
Great. Great.
because nobody was doing anything to carry into the doctor, you know, right? Anyway, right of the thing will be.
No, no, that is exactly
All the sure money given by nothing.
that exactly Nasi Bhubaneswar also we like to move that direction, touching to the society. I'll bring president here next meeting, Professor Vinod Singh, who is your earlier collaborator and my friend, because he is a new president. I'll answer that question. I will answer that question. So what Nasi is doing, they are giving funding through local chapter two way. One, the program what we have done for morning, to educate and to discuss something towards science to the society. Another one, they are asking that you submit a small research proposal which is related to the society, like the way what you discuss, and there is a separate funding for that. And as I told you, the Nasi, they have budget of like a 70-80 crores per year. This fund come from Department Science and Technology, all academy, all three academy. And they decide, so they this time also they asked me, Professor Kundu, if you want to submit a proposal, you submit it after 31st March 2025. And through that kind of proposal, along with Sophitorium, we can submit and get correct. Right. Correct. So these are two components. There are two components. Money is not the issue at all. Today, government of India for this type of no, I am talking Nasi also. Their money coming from government. Nasi or itself. No, no. Today's world only publication is not the no, no. Publication is fine, but beyond publication today you have to do this thing. Correct. No, our problem compared to Western world, they publish and from the published paper they make a product. But in our system we publish it and then that's all. Go 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 to MIT, Harvard, Stanford, Johns Hopkins and do. That guy named Bob Langer, he has a chartered flight, 300 company. Each PhD students work his lab and after completion of the PhD degree, start a new company. Bob Langer, MIT, Harvard. Right, right. Yes. So we need to discuss. We need to have a some brainstorming, some discussion. Maybe we'll make another model. Being those local 5, 6, 7 institutes, 1, 2 representative, identify that new area, and then 3, 4 hours discussion. Let's do that. Thank you again.
We are deeply thankful to Dr. Anil Chatterjee for your enlightening talk. I would request Professor Gopal Sekundu to please present the moment to Dr. Anil Chatterjee.
Thank you very much for remembering me. Yeah, yeah. Money here,
As we conclude this session, we thank each one of you for giving out your time and effort, and it has brought immense value to this session. Your contributions have made this event a huge success. We would also extend our sincere thanks to the organizing committee for their unwavering support and timeless efforts in making this event happen. A special thank you to the host institution, Sophitorium, for providing the platform and resources that enable the today's gathering. Your continued support of academic and scientific events like this will ensure the growth of knowledge and collaboration across various fields. Once again, on behalf of everyone present here, I would like to express my deepest gratitude to all those who made this event a success. We wish you all a very wonderful journey ahead. Please do join us at the Sophitorium Fest. Thank you.
So she is actually working with me as a research officer, and she is taking care, coordinating my all INSA and Nasi activities last 2 years, and it will continue next 5 years. So therefore,
Let's give a big clap to her. She did a wonderful job throughout the day. It's always a privilege to get a momentum from your boss. So now I request all the gathering here, let us join in the Sufi Fest. People are waiting eagerly there, that side. So let's enjoy for some time also. We had a good brainstorming throughout the day. So now let's move that side. Thank you very much. And all of you, please let us, after this evening, we'll have the dinner and then discuss.
yeah. Thank you. Everything went well.